We are the principal astute life in the known universe. I mean, imagine that we're the fundamental place where there is information in this inestimable framework. Cosmologists all through the world are in awe of this ever-evolving disclosure. The James Webb Space Telescope has gotten the subtle shimmer of city lights an unfathomable 7 trillion miles away from Earth, outperforming all suspicions. This amazing achievement achieves more than simply expanding our perspectives as far as what we know about the universe. Speculation goes wild as scientists pore over the data searching for signs that could unlock the secrets of these puzzling, glorious guides. The ideas are astounding. Could we be in good company in the universe, that it is teeming with life and activity far beyond our capacity to comprehend? Is it possible that these far-off lights indicate the presence of extraterrestrial societies? What does this mean for our understanding of the likelihood of life in the universe beyond Earth? Join us as we examine how the James Webb Telescope just saw city lights 7 trillion miles away. Shipped off into space on Christmas Day 2021, the James Webb Space Telescope was intended to surpass the deeply grounded Hubble telescope in capturing remarkably sharp photos of newly discovered brilliant objects, planetary systems, and more. A sensible goal of the JWST is to concentrate on the advancement of the primary galaxies by investigating the distant local populations of the universe. This is pragmatic due to the fact that the journey time of light throughout our universe is billions of years. When the JWST collects light, it captures these objects as they were billions of years ago. Space specialists measure distances in light years, which is the distance light can travel in a year. To address this reality, the gathering's fundamental practical effort focused on a significant field image presented on July 11, 2022, by President Joseph Biden while he was speaking from the White House. As the Hubble Space Telescope focused on a single area of the sky for 10 straight days beginning on December 18, 1995, the significant fields gained standing. The region was only a little spot, making up around 1/1,000,000th of the entire sky. The majority of the 3,000 currently inconspicuous things found by Hubble were enormous galaxies tracked down billions of light-years away, with its point of intermingling on the SMX 0723 World Gathering. The JWST's significant field covers a similarly small sky region. The genuine system SMX 0723 is 4.6 billion light-years away, and the more distant galaxies behind it are intensified by serious areas of strong gravitational fields. The establishment inestimable frameworks are disfigured into enormous twists where the gravitational field is most potent. In one case, it was checked that it took a distant world's light 13.1 billion years to arrive at the telescope after journeying through space. The light that is being conveyed stretches out as the universe develops. The chief objective of the JWST has broadened evident light from their stars into the infrared. Stargazers can clearly contrast JWST images and observable light photos of nearby galaxies taken by Hubble and various telescopes. By gathering data at those frequencies, this will show how galaxies evolve over tremendous timescales, enhancing and merging into the structures we observe today. More astonishing than the sheer number of galaxies in the JWST's first significant field image is how quickly it was captured, in just hours as opposed to days for earlier telescopes. Wherever it looks, it cannot resist the urge to chase down galaxies. Galaxy clusters aren't the principal objects acting as enhancing centers. Analysts used the JWST to capture an image of several galaxies designated VV1191 to focus on how the light from one of the pairs changed as it passed through the other. The delayed consequences of the assessment will reveal the properties of the interceding astronomical framework buildup. Furthermore, it looks like the JWST may have recently made an outstanding discovery light-years outside our close planetary group. The announcement of the possible exposure of auroras on an indicated brown dwarf came from the official JWST site. The absence of a host star and the frigid temperature make it challenging to pinpoint where the energy in the upper atmosphere is coming from. However, the fact that the object producing auroras is hurling methane is critical. Similarly, as an aurora on Earth is created when energetic particles from the Sun are captured by our planet's magnetic field, resulting in a brilliant display of light known as the aurora borealis. Jupiter and Saturn have similar auroral phenomena due to the solar wind. However, the hardy-colored brown dwarf W1935 has no star to orbit, so its auroras remain a massive mystery. Everyone's assumption continues to lay on Proxima Centauri and TRAPPIST-1, only 4.4 light-years from Earth and within the Milky Way system, with analysts identifying the presence of water on the exoplanet. The chance of life in this world cannot be dismissed. Are we finally going to see evidence of life beyond Earth? Just last month, the JWST observed another extremely massive black hole, measured in mass and consuming everything around it. This revelation is 40 million times as extensive as the Sun. What does it mean for us? The JWST has found that this exceptionally large black hole has been there since the beginning of the universe. It most likely will not be inspiring news, as this monster is rapidly devouring everything in its nearby region. The discovery is attributed to Dr. Lucas Fu and Professor Alistair Zittrain of the Ben Gurion University of the Negev in Israel. According to their revelations, the supermassive black hole is for all intents and purposes multiple times heavier than the Sun, making it a monstrous entity that stands out from the galaxy it resides in. Fortunately, it is not a threat to Earth or the nearby planetary group. We're talking about an immense distance of 129 billion light-years from our planet. Nonetheless, it is moving closer, with the black hole consuming everything around it at a rapid rate, where the red color indicates that it sits in a dense cloud of buildup that is obscuring light. When the JWST began sending its initial data, scientists were thrilled while sifting through the information from the Uncover program. 3 small things with a dull red glow caught our attention, and we rapidly assumed they were black holes. Truly massive black holes at the centers of galaxies are constantly gathering material, and their red dot appearance can be misleading. The entire galaxy's brilliance proved unable to be contained within a spot no larger than a modern-day star system. We had the chance to greatly obtain definite size constraints due to the source's gravitational lensing. Even when all of the potential stars are compacted into that small region, the black hole still represents something like 1% of the structure's total mass. The discovery of similar approaches to acting in various early universe supermassive black holes has revealed insights into the evolution of both the black hole and the host galaxy, as well as the relationship between the two, which is still commonly obscure. If very massive black holes are formed from stellar remnants or maybe from early-stage cosmic material that collapsed into black holes, space specialists cannot directly see them in the photographs sent back to Earth. The James Webb Space Telescope is discovering some other rather strange things regularly. We have the pleasure of exploring space and being enraptured by the astounding lights of planets and stars that float across the universe, unending light years away. Notwithstanding this, the James Webb Space Telescope allows us to see much beyond what our eyes can perceive. For example, a question mark in space has been observed. For the past 20 months, Webb has been drifting through space, sending back pictures of what it has discovered in insignificant space using its cutting-edge near-infrared camera. Moreover, answers have been given to the discovery of a genuinely unusual-looking finding in one Webb picture, focusing on something completely different. The picture was conveyed by the European Space Agency, seeing 2 young stars as they form some 1.47 light-years from Earth. However, there is a minimal orange mark at the image's base that seems to resemble a flipped question mark. Obviously, this little image isn't nearly nothing. In actuality, it's quite colossal. The question mark was captured while observing the arrangements of young stars named Herbig Haro 4647. These immense stars are surrounded by colossal circles of dust and gas, some thousands of years old. As for the question mark shape itself, it may well appear to be an optical illusion due to the two-dimensional image presented by Webb from its specific viewpoint. At this moment, we do not have even the remotest clue what it is, and without additional examination, we may ultimately never know. However, the discoveries have intrigued experts in the field, thus it is likely a distant galaxy or possibly galaxies that are connected to one another. The ruined inquiry mark design could be a result of their coordinated efforts, making it challenging to determine its character with any degree of certainty. Further assessment is indispensable, as with the flood of faraway grandiose frameworks unveiled by Webb, there is a surge of new scientific inquiries. By now, everybody's eyes are focusing on a specific set of Earth-sized planets that could hold the key to finding extraterrestrial life. The firmly Catch-22, which involves the non-appearance of evidence for advanced extraterrestrial life in the universe despite the high probability that such beings exist, could finally be settled. Where are these planets situated? approximately 40 light-years from Earth, and the nearby planetary group is a star known as TRAPPIST-1, which has 7 planets orbiting it. In their quest to find habitable planets, NASA considers a wide range of limits beyond a planet's size and distance from its star. A more suitable strategy is to identify the general concentrations of these elements in a planet's current environment, which would allow experts to determine whether the planet is habitable. The Infrared Spitzer Space Telescope, which is a part of NASA's space exploration mission, helped in the discovery of the 7 rocky exoplanets orbiting TRAPPIST-1 several years ago. The James Webb Space Telescope has now assessed the temperature of TRAPPIST-1b, one of those worlds. The JWST has been continuously providing significant discoveries since its launch, and this finding is merely the latest in a line of record-breaking firsts. This is the first revelation of light emitted by an exoplanet as small and cool as the rocky planets in our own nearby planetary group. No telescopes have had the capability to measure such weak mid-infrared light. Space specialists were pleased when they first learned about the 7 TRAPPIST-1 exoplanets, as these distant worlds are all roughly Earth-sized and lie in the habitable zone, the region where planets can have liquid water on their surfaces at the optimal distance from their star. They call the system an exceptional research center and say it's perhaps one of the best spots to focus on rocky planet conditions. The TRAPPIST-1 planets may not turn out to be overly promising for life as we know it. However, the planets are out of our current reach at an astounding 235 trillion miles away. They also orbit a star significantly more diminutive and redder than our Sun, known as an M-dwarf star. These stars are many times more common in the Milky Way than Sun-like stars, and they have increased the likelihood of having rocky planets compared to Sun-like stars. These colossal M-dwarfs are ideal targets for habitable planet trackers, and rocky planets revolving around these small stars can be more easily observed. There is a catch. M-dwarfs are typically more volatile than our Sun and frequently flare, emitting high-energy bursts that could be detrimental to emerging extraterrestrial life or a planet's atmosphere. Prior views of TRAPPIST-1b were not sufficiently precise to rule out the potential for an atmosphere or the planet's viability as a habitable world. Since the planet is tidally locked to its star, one side is constantly facing the star, while the other is trapped in eternal darkness. As suggested by simulation, if TRAPPIST-1b had an atmosphere, the temperature of the planet would be lower since the air would moderate the temperature around both sides. Nonetheless, the JWST measured a much higher temperature, further undermining the credibility of an atmosphere and eliminating another planet from the list of potentially viable worlds. What could life on these planets look like? The James Webb Space Telescope has taken on the role of an extraterrestrial meteorologist, engaging in some space investigation. Ultimately, the superlative piece of space has been utilized by a group of global space specialists seeking to harness its powers across the universe. This is merely the beginning of its astronomical endeavors. When it comes to atmospheric conditions, Webb has been precisely analyzing what is happening on a massive planet located around 280 light-years away, or approximately 1,644 trillion miles from Earth. The planet, known as WASP-43b, is roughly the same size as Jupiter and has been classified as a hot Jupiter by NASA. After its discovery by the Hubble Space Telescope in 2011, the weather patterns were hypothesized to be 1,250 degrees Fahrenheit with tropical winds exceeding 5,000 miles per hour, concealed under thick, high clouds covering the night side of the planet. The reason for this is that WASP-43b is perfectly locked to its star, meaning that while one side is constantly exposed to the light from the nearest star, the other side remains in complete darkness. By combining precise brightness measurements over a broad spectrum of mid-infrared light with 3D climate models and prior insights from different telescopes, Webb was able to confirm that water vapor is present on the day side. While Spitzer and Hubble both hinted at the possibility of clouds on the night side, extra precise readings from Webb were crucial before we could begin to assess the planet's current atmosphere. Cloud cover, wind, and atmospheric circulation vary across WASP-43b, which takes 19.5 hours to orbit its star. With the JWST measuring minute changes in the brightness of the planet and its neighbors, Webb utilized brightness data collected by its advanced near-infrared camera to determine the planet's temperature. The amount of mid-infrared light emitted by an object is directly related to its temperature, which was critical to the results for which measurements were required every 10 seconds for more than 24 hours. We were able to establish a rough estimate of the planet's temperature from our findings during a full orbit, allowing us to assess the temperature of the various sides of the planet as they appeared. The side of the planet that is perpetually illuminated by sunlight has an average temperature of close to 2,200 degrees Fahrenheit, which is sufficiently hot to melt iron and most other metals. The dark side, while still warm, is generally cooler, sitting around 1,125 degrees Fahrenheit. The rapid dispersal of heated air due to supersonic winds prevents the formation of methane, a common and recognizable gas on the obscured side of the planet. The fact that this method of temperature measurement is feasible is a clear indication of how sensitive and stable Webb is. Analysts can glean from the absence of methane that WASP-43b experiences winds exceeding 5,000 miles per hour.